Before a browser can load a page, before a packet even finds its destination, there's something watching silently in the background, ready to speak up when things go wrong. It doesn't carry your data, it doesn't need a handshake, and you don't notice it until there's a problem. This is ICMP, the protocol behind every ping, unreachable destination, and silent network failure. In this video, we'll break down how ICMP works, why it's essential for the internet to function smoothly, and at the end, we'll build a simple latency checker in Go, using ICMP messages to ping hosts and measure response times ourselves. Let's jump in. And what is ICMP? ICMP, or Internet Control Message Protocol, is a support protocol used by many network devices to send diagnostic or error messages. It helps report issues like unreachable hosts, network congestion, or packet timeout, problems that the IP protocol alone can't handle. Rather than carrying user data, ICMP messages are used to keep the network running smoothly by helping devices identify and respond to connectivity issues. It's the protocol behind tools like ping and traceroute, and while it's essential for maintenance, it's also widely used to perform DDoS attacks. When we talk about ICMP message schema, it's important to notice that the messages are transmitted using IP datagrams, or IP packets. The whole IP datagram will have an IP header of 20 bytes, and the ICMP message, whose sizes vary. The ICMP v4 message has basically 4 fields: the type, the code, the checksum, and the content. The type can have up to 8 bits, the code 8 bits, the checksum 16 bits, and the message content will vary its size. As the type can have up to 8 bits, 2 to the power of 8 is equal to 256. So it can have up to 256 types. However, in reality, there are much less ICMP protocol types that are used internally. And the same logic applies to the code of the message too. The type field defines the purpose of the message. What type of message is being sent, like a ping request, a reply, or an error report. The code, while the type field tells us what kind of the message it is, the code field gives extra detail, like subcategory or specific reason within that message type. It adds context to the type. For example, a type 3 is used for destination unreachable, with a code 0 would be for network unreachable, code 1 for host unreachable, and 2 for protocol unreachable, and so on. The checksum is a small piece of data used for error detection. When a device receives an ICMP message, the protocol recalculates this value to check if the data got corrupted. Unlike TCP checksum, on ICMP it's used only for error detection, not for error correction. So if the data is somehow corrupted, it will be discarded. Message content, and when something goes wrong, the destination device sends back an ICMP message, right? This message includes the original IP header and the first 8 bytes of the data that caused the issue. That's usually enough to identify the protocol used, like TCP or UDP, and figure out what went wrong. Now that we understand more about this powerful protocol, let's get our hands dirty and implement a latency checker tool using Go. So here I am at my IDE, and let's create a file. And we will need 3 things. The first thing will be a struct to store our connection. The second thing will be a constructor to instantiate the connection. and all fields on our structure really, and the actual ping echo request. So I will call this structure like monitor, I think. I will have a con, which will be from ICMP. So yeah. Can I get this thing? Yes, I can. And yes, this will allow us to instantiate a new connection for sending ICMP packages elsewhere. And the method that we want is listen packet, which if you see here, go mod tidy. Sure. You see here, inside this method, this method, we need to pass the network itself and the type of the network and the address, right? So I'm gonna use an IPv4 address, network address, and yeah, we need the host here. So no, actually, not actually. I'm gonna this thing I want to go to my loopback interface, my local host. So it must be 000. And if I have any error, I will return this error. I will return the monitor with its fields populated and no errors in case no errors happened. Right, so I will have a pointer method for this ping request. And this ping request requires a string of the host itself that I want to send the actual ping thing. And as it is a ping, we need a way to track its time duration, right? And the time duration and the error itself. So, however, I want to be able to pass not only an IP from this host thing. I want to pass the host name too, if I want, the DNS, whatever. And we need to find a way to resolve this IP address in a way that we always get the IP address to send the data to. And the way that we can do that is with the resolve IP address from the net package inside Golang. And the first parameter is just the network type. And the network type, as we specified before, is an IP4 network, and we shall pass the host itself. If I get an error, I will return a 0 and the error itself, because yeah, that's no duration on that case. Now we need to make the message itself, the ICMP message itself. And the way you can do that is literally just calling message from ICMP. If you go right here and check this thing, you can see that we have the type, the code, the checksum, and the body. right? So everything that we have is studied before. And the message body too. Yeah, let's go back right here. And the type I want to pass an IPv4 echo, type echo, yes. The code will be 0 for network unreachable. And by the way, you can find all these codes on iana.org, iana.org, so you can find everything there. So yeah, the body itself will be, as you can see, the body is a message body. Let's see what we have here. Sure. And what we can do is pass the ICMP echo, and we need to pass an ID first, as we can see here. And this ID is really important because when your data reaches the other end, the operating system kernel needs to know to who it will route the data back, right? So it is for routing purposes. So one way we can do that to give a great ID to this message is to get our process ID. However, the process ID can have much more than it can have like 32 bits, 64 bits. And we don't want that. We just need 16 bits. And we can always get the last 16 bits from our process ID. And the way you can do that is by performing an AND operation with the maximum number that we can store in 16 bits. And the way you do this is performing an AND with the number 65,535. And yeah, now the sequence is also really important to identify our requests, because you can't be sending like a lot of requests to the server and it doesn't respond right away, and it can like take a while and store like 10 requests there and respond all of them at once, and you don't really know which is related to what, you know. And this is another identification. And if you are sending like a lot of requests, let's say, I don't know, 100, it will keep doing the sequence. For yourself, we will do only one sequence, no problem. And the third parameter is the data itself, which is of type byte. We can send only hello, so yeah, no big deal. Yeah, sure. Now we need a way to marshal this thing. And if you see right here, you actually have a marshalling function, which is implemented by the protocol itself. You don't have to implement that. So each type of message will implement a marshalling thing differently. And you don't actually need to perform this thing. We will only call this and a null, because we don't need this. Let me copy this error to make things quicker. And yeah, now I want to store the actual time that I'm performing this operation, so we can see how much time it took to for end response to get back to us, right? And I need to write this data to this IP address that we got right here, right? So the way we can do that is with the method inside our monitor that we can write to, right? And this is how we can do this. And what's this error about? Yeah. Now I want to read this thing from this thing. However, I don't want to read like to keep reading to read like forever. So we can set a deadline inside this thing. So yeah, inside this thing we have a method for that, I'm pretty sure. And here, by the way, guys, if you like this video somewhat useful, leave it a like below, subscribe to the channel. We will have much more videos like that, and type below what you want to see in future videos. And I want to get this data too, and we do have a method for that too, which is a read from, which receives yeah, it must receive data. So let's actually make this thing. I think that will be type byte, as you saw it in the parameters, and I think that 200 bytes is fine. And this thing returns an integer, which is the amount of bytes read, the net address, and in there. So we just need the first one and the last one. Right, and the reason why we need the amount of bytes that we are reading to is because when we want to parse the message, we want only to read the correct amount of data needed. So yeah, and inside ICMP, I will parse the message, and the type of the protocol that we are using is IPv4 and ICMP type echo reply, protocol, and we will pass the reply and only the amount that we need to. So yeah, and this thing returns the message read and error. And if the type is actually an type echo reply, we want to return the duration of this thing. So yes. So right now we will just instantiate a new one. If I got any error, let's just let's call for Google. And now we need to close the connection because otherwise it will be idle and we don't want that. Oh. Oh yeah. Right here we have to specify that it's a IP4 ICMP network. Not permit, so we have to run as a sudo. Yeah. And just like that. That's one way of doing this, of checking the latency of a device or a network or a server. Now let's improve this code. I want to be able to manage multiple hosts and do that concurrently, so it will be a little bit faster. And the first thing that we need is a multics here. And the thing why we need a multics here is because for each host we will call that inside a Go routine, and we need to lock the socket for that specific routine. And the way we will do that, we must lock the socket before writing to it. So yeah, another thing that we need is different sequences for each coroutine, so we can identify that then differently. Yeah, right here, another thing that I want to do is to get the actual body that we received inside our read message, type it, so we will be able to really check if that sequence is of that specific coroutine that is calling this ping function. So the way you can do that is by doing some what is it, call it ICMP echo. Yes, we need an actual echo message here. Um, we are just ensuring that we are getting the same type of message as this one, which will be an echo reply message. Will have the same structure. Sure. Mm. Another thing that we need is to a way to store our ping result, to format this thing. And yeah, I will show our host the duration itself, and I want to be able to see the actual error that was returned. And yes, let's make a ping multiple function, which will be a pointer type, pointer method. I will make a channel of ping result here. That's the type that I want. And the length of this channel will be the same length of our host. Now, I want to range over this host. And for each host, I will call concurrently. I will perform a ping to that host. And yeah, we can do that here, but I don't really want to do it. I will make a separate function for that. Will be a ping host function, which will also be a pointer method. And I want to pass the host. We actually the sequence to, and the channel, which will be a receiver channel. It returns nothing because we will return inside the channel itself. So right here we call the actual function. No, I don't want to return the error actually. And yeah, inside this channel, I will return the ping result itself. Host, duration, error. And in here, I can call this thing concurrently now, which will be fine. And passing the results itself. So right now I need to store all these ping results that was called here, and yeah, will be an array, and I will range over the length of the host itself, and for each one of them I will be appending the results. Let me do it like that actually. And the receiver channel. Yeah. Now, let me, why did I do that? Yeah, whatever. let's declare our hosts, which will be an array of string google.com. Let's call Cloudflare. Let's call github.com. And let's also call let's call Google again. Why not? Yeah. In here, being multiple with hosts. Yes. And now let's hang inside this results that we want to. And if the result is an error, I want to have a different message for it. So this way, yeah, we can handle it separately. I will pass the host and the error itself. Right, and else I will return a okay. Yes, this thing is fast, boy. Let's not do that. Oh yeah. We must get the duration itself. Yes, and just like that, we can get the latency of a lot of hosts concurrently. And as I told you guys before, if we don't have this, we will get a bunch of error here because the socket is actually being used by other coroutines and it's locked. So yeah, you actually really need that. And that's it for today's video. Leave it a like below and subscribe to the channel.